Today we're going to talk about the second most important formula in trigonometry, or at least the way I see it. But before we're going to talk about it, obviously the most natural question to ask is, what is the first most important formula? What is the most important formula in trigonometry? And in my opinion is this formula. That's the formula, and what I think is, if you want to know one formula out of trigonometry, one formula to remember, this is the formula you should remember. Okay? Today we're going to talk about the next most important formula. In fact, it's not just one formula, it is 4 formulas. It's a sine and cosine of sum and the difference of 2 angles. That's what we're going to talk about today, and we're going to kind of derive those formulas. So let's get started. So what we're going to do, we're going to again get our unit circle. We're going to draw point A, which is represent angle X, and point B, which represent angle Y. Okay? So, and what we would like to know is what is the distance between point A and B. Before we do that, just remind you that point A has coordinates cosine x, sine x. Point B has coordinates cosine y, sine y. And since we're interested in that distance, AB, also a good thing to remember the formula. How to calculate the distance between 2 points if we know the coordinates of both points. So, and this is the formula that we're going to use. So if x, a, y, a are coordinates, horizontal and vertical coordinate of point A, x, b, y, b are coordinates of point B. In this case, ab squared will be, xa minus xb squared plus ya minus yb squared. And that is the consequence, actually, of Pythagorean theorem. So if we apply this formula to our points A and B, we're going to have an expression like this. The next thing we want to do, we want to open up this parenthesis. We have cosine x minus cosine y squared. And then we have sine x minus sine y squared. So we want to get rid of parentheses. And to do that, again, we want to look at the following formula. It's a good formula to remember. How to open up the square of the difference between 2 numbers. All right. So if you use this formula and open up the both parentheses, we're going to have an expression like this. Okay? So the first 3 terms on the top, it's what happens if you open up the first parenthesis for cosines, and the second 3 terms, it happens if you open the sines. Okay? Now the next thing you want to see is what's in those rectangles, red and blue. What we have here is cosine of an angle plus sine of the same, cosine square of an angle plus sine square of an angle. And as we talked earlier, this is probably the most important formula in trigonometry. And that formula tells us that if we take cosine square plus sine square, we're going to get 1. So there's 1 in red rectangle and 1 in the blue rectangle. So our formula simplifies and becomes like this. Okay? So let's put it at the very top and look at our picture again. Now, if you look at the picture on the left, what we're going to do is this, like imagine this piece of paper. And what we're going to do, we're going to turn this piece of paper by y, angle y degrees or y radians, depending how you define x and y, within radians over degrees. And we want to move it clockwise. So we're going to do something like this. If we do this, line OB becomes a horizontal line for us, right? But because we move whole picture, okay, whole picture, the distance between A and B did not change, and that's very important. So what we're going to do next is, if you look, the angle here is angle Y, here is angle X. So the angle between OA and OB obviously going to be X minus Y. Okay. The next thing we're going to do is we're going to change our coordinate system. Instead of having it like at an angle, we're going to make it straight. Horizontal axis now is going to go through points O and B, and the vertical axis is going to be at 90 degrees to it. You're going to have a picture like this. Again, what we did is we turn the whole picture, and then we put a different coordinate system. Okay, that did not change the distance between points A and B, but this did change the coordinates themselves of point A and B. So coordinate of point A becomes cosine x minus y sine x minus y, just because this angle is x minus y, and point B has coordinates 1, 0. And again, what we're going to do now is we're going to calculate the distance AB using coordinates of the points A and B. Again, by the rule we discussed before, this is what we're going to get directly. It's a horizontal coordinates, difference between horizontal coordinates, cosine x minus y minus 1 squared, plus the difference between vertical coordinates, it's sine x minus y minus 0. Again, we see over here, square parenthesis with squared. We're going to open up using the same formula as before. And what we have in another parenthesis, well, there's 0, so it's really just sine x minus y squared. So this is what we're going to get. The first 3 terms represent the first parenthesis. Okay. Now again, we see this. We see cosine square of an angle and sine square of an angle. And that is 1. So in our formula, becomes like this. It's very simplified. So let's rewrite both of these formulas. Both of these formulas represent the same distance between points A and B, just in different coordinate systems. And obviously, they have to be equal to each other, right? So this is our expression. The next thing we're going to do, we see there's 2 on the left, 2 on the right. So we're going to subtract 2 from both sides of this equation. Get something like this. Now you see there is minus 2 sitting in front of every term. So what we're going to do now, we're going to divide by minus 2, both left and right hand side. And we're going to get the formula we were looking for. This is the formula of cosine of the difference of 2 angles. Okay? Let's put on the very top. We have it now. And let's look at the next formula. Is it cosine of the sum of 2 angles? Cosine of x plus y. Okay. Now, once we have one of those formulas, now everything else becomes much easier. We don't need to use the unit circle. We don't need to rotate any coordinate systems. We don't need to do anything like that. We just need to be a little bit inventive. And the question is, what is cosine of x plus y? What we can do, we can rewrite as x plus y as x minus y. And now we got ourselves cosine of the difference between x and minus y. And we can apply the formula at the very top of cosine of the difference to this expression. The only thing we have to do, in the expression on the top, we have to replace y with minus y. And this is what we're going to get. The next thing we need to remember that cosine is even function. So we have to deal with cosine of minus y and sine of minus y. Cosine is even function, which means that it doesn't care whether it's minus or not. It ignores it. Sine, on the other hand, is odd function, right? And what it means that that minus comes out outside of the sign, okay? And we're just going to use these formulas to simplify what we have here, okay? Once we plug this in, we're going to have a formula like this, okay? Pretty easy. As long as we remember that cosine is even, sine is odd. So we got 2 out of 4 formulas. Let's move on. The next thing is a sine function. Now, actually, we can get to sine from cosine. We just need to remember a formula from one of the previous videos. That sine of an angle, we call it z here, is a cosine of pi over 2 minus the same angle. And just remind you, if you're not used to radians, pi over 2 radians means 90 degrees. Okay? So from now on, I'm going to use radians because that's what kind of normally is what's being used in algebra, in most of the math, in physics. Radians are more convenient units than degrees. All right, so what are we going to do? So we're going to take a sine of the difference, and we can represent this using this formula right here as a cosine of pi over 2 minus that difference. If we simplify it, we get pi over 2 minus x plus y. And the next thing I want to do is I'm going to consider pi over 2 minus x as one angle, and y is the other angle. And in this case, I can use this, I can assume that, and use this formula for cosine of sum of 2 angles. Okay? If I do this, I'm going to get something like this. All right. And the next thing, what I need to do is I need to look at cosine of pi over 2 minus x and sine pi over 2 minus x. You already know from the formula here that cosine of pi over 2 minus anything is a sine of that anything, right? This is what's written here through x, not through z. In a similar way, sine of pi over 2 minus x is cosine x. And what we're going to do, we're going to substitute these values in the previous formula. And we're going to have our formula for sine of the difference of 2 angles. Okay? Here we go. You know, we want to find a sine of the sum of 2 angles. And we're going to do it in a similar way as we did for cosine, how we went from cosine of the difference to cosine of the sum. We take sine of x plus y as sine of x minus y. And now we're going to use previous formula for sine of the difference of 2 angles, where we basically replacing y with minus 1. That's all that happens here. And now we have to deal with cosine of minus y and sine of minus y. Again, we remember that cosine is even function. It doesn't care whether it's minus or not. And sine is odd function where minus just comes out outside of the sign. And if you use these formulas, we're going to have our sine of sum. So let me now write all these formulas together. Just look at them one more time. These formulas are very useful. That's why I call them the second most most important formulas in trigonometry, and I personally remember them. Okay, if you're gonna deal with trigonometry on a regular basis, it's a good thing to remember. See you in the next video.